Selamat sejahtera. My research is about a study on the potential posed by the porous ceramic and porous metal in generating the glow discharge. Next, where we can apply the glow discharge plasma. It is well known that glow discharge plasma has a broad range of applications such as mitigation of the pollution in controlling car exhaust emission, surface treatment in semiconductor industry, in activation of the microorganism in food industry, the plasma treatment on the skin care in the medical industry, and also the plasma ignition combustion in the aerospace industry. However, there is some problems in the conventional glow discharge plasma generation, such as low pressure is needed, very costly equipment due to the vacuum system, glow discharge plasma are normally unstable, and also we believe that the porous structure materials have a better performance in generating the glow discharge. Hence, the main objective of this research is to investigate the effectiveness of the porous structure material in providing a stable glow discharge plasma at the atmospheric pressure. In order to compare the effectiveness of the porous structure material with the conventional used material, 4 configurations have been investigated in this research. The high voltage AC/DC kit was used to apply the high voltage onto the discharge chamber, and the voltage divider was used to attenuate the high voltage onto a lower voltage and can be shown on the oscilloscope. The oxygen gas generator is used to feed in the oxygen gas to the discharge chamber, and 50 ohm resistor is used to generate the discharge characteristic, and the 20 microfarad capacitor is used to record the Lissajous figure. Next, I will continue with the results of the experiment. So this is the visual observation of the typical glow discharge plasma, which is in purple color. Since visual observations are clearly inadequate for comparing the stability of the different discharge, 2 familiar discharge behavior techniques were adopted, which is the voltage charge Lissajous figure and also the characteristic of the discharge current. The observation of the voltage and discharge current waveform were obtained and recorded. So this is the example of the configuration with fine wire mesh as electrode and glass sheet as dielectric. So as we can see, at 7 kV, the gas starts to break down, and one of the half cycle consists of single pulse current discharge. And when the voltage is further increased to 7.4 kV, the glow discharge was generated, and it is indicated by single pulse discharge current in both of the half cycle. However, when the voltage is further increased to 7.8 kV, the glow discharge has started to change into mixed glow filamentary discharge. And finally, it will become a pure filamentary glow discharge at 8 kV, where there are several current pulses in each half cycle of the input voltage. A voltage charge Lissajous figure was obtained, and to verify the results obtained from the voltage discharge current waveform. So for the configuration with the fine wire mesh as electrode and glass sheet as dielectric, at 7 kV, the voltage across the gap is insufficient to cause the gas breakdown. So the voltage and the charge are in same phase, and the plot of the Lissajous figure is a straight line. As the voltage further increased to 7.4 kV, the straight line slowly turns into an approximate parallelogram with only top and bottom sides as shown in the second figure. And the third figure indicates a mixed glow filamentary discharge by the staircase-like regions of this waveform at 7.48 kV of the applied voltage. And finally, the waveform turns into a regular parallelogram where there is the presence of the connecting lines in the staircase-like regions, indicates a pure filamentary glow discharge at 8 kV. voltage at each phase for each configuration was tabulated in the table based on the results obtained from Lissajous figure and also the voltage discharge current waveform. We can see that for the configuration with the porous metal as metal electrode and glass sheet as dielectric, it has the lowest applied voltage to initiate the glow discharge plasma. As reported in the literature review, appropriate hole size of the metal electrodes which approach the mean free path of the feed-in gas is believed to produce a more stable glow discharge at atmospheric pressure. Since the porous metal have a feature of gas penetrability, the oxygen gas that feed into the gas chamber is enabled to diffuse through the porous layer. An extremely uniform distribution of the gas flow will then allocated along the entire area of the porous metal, and therefore the plasma intensity was strengthened. For this reason, only a lower applied voltage is needed to initiate the glow discharge plasma. Then we also can see that for the configuration with porous metal as electrode and porous ceramic as dielectric, it has the largest range of applied voltage among the others configurations. This result has further strengthened the conviction that the porous alumina ceramic can help in sustaining a stable and homogeneous glow discharge plasma due to the existence of the micro-holes. There is the massive existence of asymmetrical micro-holes with diameter up to 100 micrometer in the porous alumina ceramic, and these micro-holes will trap and confine the electrons, which will contribute to the increment of primary seed electron in the next discharge cycle. This implies that the porous structure material can improve the capacity in storing ion and the electron, which can help in enhancing the glow discharge plasma. Table 2 compares the data on the maximum charge transfer at each phase for each configuration based on the results obtained from the Lissajous figure. So as detailed in Table 2, we can see that the maximum charge transfer was gradually increased with the applied voltage from phase to phase, which depicts that the number of the charge transfer is directly proportional to the applied voltage. Besides, it was found that the configuration with the porous structure material have a larger value of charge transfer during the discharge compared to other configurations. On combining the results tabulated in Table 1 and Table 2, we can see that as the value of the maximum charge transported between the electrodes increase, the lower required applied voltage is needed to obtain the glow discharge plasma. The time constant for a single discharge and the duration between two consecutive single discharge for each configuration at the glow discharge phase were measured from the current waveform and was recorded in this table. So from this table, it is apparent that the configuration with the porous structure material have the longest duration between a single discharge compared to other configuration, while the configuration with the combination of wire mesh and the glass sheet has only 9.76 millisecond time difference between two single discharge. The time constant of each single discharge will be affected by the electric field strength and also the charge up condition of the dielectric sheets. This tabulated data also depicts that for the configuration which use the porous structure material will help in sustaining the single discharge for a longer period, since the time constant for this configuration is the largest. In summary, we can say that the glow discharge produced by the configuration with porous metal as electrode and porous ceramic with dielectric is the best configuration compared to other because it is able to provide stable glow discharge plasma at a low supplied voltage and for a larger range to change into mixed glow filamentary discharge. And also because the porous structure material contains the pores which is in micron size, which will produce a hollow cathode effect and enhance the glow discharge plasma. Also because the existence of the micro holes that are filled with the air, When the gas will break down, the discharge will generated and the current flows through the microchannels in these microholes will increase the probability of the electron emission and also increase the primary state electron. That's all for my demo video. Thank you for the attention given.